is a 24, 171. And that is g of x equals the cube root of x to the fifth plus 6x. If it's anything but the square root, I have to change it into, as we know, any radical is a power. But it's an ugly power. It's a fraction. The power is a fraction for any radical. If this were, we'll continue in a minute. If this were, for example, let's say g of x equals the square root of x to the fifth plus 6x, I would have never done that, because there is a very easy formula that says 1 over 2 the square root times the inner function prime, and you're done. But because it's not the square root, for which I have this beautiful formula, I have to do this. So then when I differentiate the first function, I have to bring the power down. I have to subtract 1 from the power. And if I forget to say times the inner function prime, then the whole thing collapses. So I have to write 5x to the fourth plus 6. And you can leave it as is. That is acceptable. Good. Next question. Anything else? Okay, so back to this page. So these are the topics that we want to look at. And let me know what you would like to start with. Or if you have other questions. You may have other questions.
We go over the piecewise defined function again?
Yes, but that is just algebra. And we had tons of examples. Are you sure that you really want to just graph a piecewise defined function? I'm fine. Can you choose one? That's fine. Just choose one. Yep, just choose any piecewise defined function. But please go back to those 5 examples that we had from the very beginning of the class. That was the first, one of the first items that we looked at. I mean, this is, as I said, this is just algebra. It shouldn't even be here. But I'll be more than happy to, of course.
It's all good. I'll just go back to the other ones.
No, but if you have one, you may not be the only one asking this, so that's fine.
It's going to take me a minute.
They are in chapter 1, towards the beginning of the chapter. I'm looking for one too. You don't even show that because it's, as I said, it's an algebra piece. So on page 125, so that's under continuity. So that's one, or page 114. 114, 125. They have plenty of piecewise defined functions.
Can we do 78 on 114?
114, 78 on 114. Yep, sure. So we have g of x equals 2 plus x for x less than or equal to -1. And we have x squared for -1, x between -1 and 3. and then 9 for x greater than to 3, and they want us to determine the limit as x approaches -1 from g of x, and limit as x approaches 3. Okay. Good. So we have to start with a domain. We always start with a domain, so we change this into -infinity, -1. We change this into -1, 3, and we change this into 3 to infinity, which tells us that the domain is, anybody? According to the intervals, the domain is? Can anyone give us the domain?
Is it -infinity to infinity?
Yes, yes, it happens that way, but this is not always the case. Good. Of course, I have to have -1 and 3 and 0. And you see the interval notation is very helpful because it will tell us which one is an open point and which one is a closed point. So under 3. So see, a bracket facing the way the left, and the parenthesis facing right, and the parenthesis facing left, and the bracket facing right. Then I will just write exactly what I see there, because between this and this I have to use this function, between this and this I have to use this function, and between this and this I have to use this function. So after that I need some points here, so I'm going to write -2 because it gives me an x-intercept. With -1, I get 1 right in front, right in the middle of the parenthesis. When I plug in 1, I also get 1. When I plug in 0, I get 0. When I plug in 3, I get 9. And on this other side is all 9. So I make sure that left and right I have a number, which means that the limit here is at -1 is 1. And the function is continuous. The same thing for 3. It happens that this function, both sides, there is no jump, so the function is continuous everywhere. And then I can graph, but be very careful how you graph it. The pieces cannot overlap. So here at -2 is 0. At a -1 is 1. And this is one piece. The other piece is a piecewise, I'm sorry, the other piece is quadratic. So at -1 is 1, at 0 is 0, and at 3, 1, 2, 3, so I'm going to say that this is 9. It's not. So that's the middle part. And then the right-hand side is 9 always. The problem can ask you to determine the range. So the range of this function is from -infinity to 9. You do not have to graph with 3 different colors, of course. I'm making a point that this piece cannot be extended, the quadratic cannot be extended anywhere, and the horizontal line cannot be extended anywhere. Good. Thank you. Next question. What would you like to? I'm saying it's up to you. Graphing the linear equation should not be an issue. A reading from a graph should not be an issue. Slope, finding the slope and the y-intercept, this should again be a non-issue. Finding limits from graphs should not be an issue. Continuity, we just discussed it here, but we can go over any problem you want. Limits, this is new, and the algebraic part is new for the class. The average rate of change, again, is algebra. It's the slope of a linear function. The difference quotient is a topic. Derivatives are topic. New topic, this is it.
Can we do a limit, number 7 limits question?
Yes.
I thought that there was one on our written homework, but I could be wrong.
Yes, any problem. So, and then as I said, I think problem 17 is the extra credit, and it may not be 17, but it's the one with 1 point. Domain of functions, again, this is just basic algebra, finding domain of a function. We can go over anything, of course. I'm just saying what are the algebra problems. So again, the exponential rules, this is arithmetic basically. Demand and supply, this is somewhat new. Cost, profit, and revenue, it may be something new, and also the average, cost, profit, and revenue. Okay, so we want to look at limits. So let's continue with limits. And I have the book open in the background. So let me open it here. Yes, it's right here. Good. So here it is. So there is a chapter test and a review for the whole thing. I'm looking at chapter 1. There are some topics from chapter R. We can go back to it. So the algebraic limits mean not reading from the graph, right? But simplifications, rationalizing, stuff like that. So I don't see them here. Well, why I don't see them here? Let's go back to okay. So so these are the 1.1, 1.1, 1.2. Okay. So you can choose. I just wanted to see what was next. Okay. So these are the limits that I was talking about. What would you like to work on?
I can't.
You want me to choose or?
Let's see. 20.
Okay, so let's work on 20. And 20 we have limit as x approaches -7, x plus 7 in the denominator, and x squared plus 2x minus 35 in the numerator. Okay, good. Oh, there was something in the chat. Yes, I saw that, Haley. Thank you. Okay, so first of all, like with all limits, I have to plug it in. There are very, very few situations in which I cannot plug in it right away. But in this case, I have to. So when I plug it in, I have 14. I'm sorry, 49 minus 14, which is 35. Minus 35, so 0 over 0. I like this because there is hope. And I know that 0 will not happen unless there is a factor of x plus 7 top and bottom. Because that's the rule for something called the remainder theorem and the factor theorem. So when I plug in 7 in a or -7 in a polynomial and I get 0, I know it has a factor of x plus 7. It must have. So now I have to figure out the other factor. Can anyone give us the other factor?
Be x minus 5.
Exactly. So once I simplify and I plug in -7, this is -12. Any questions? In preparation for the test, I will at least look at all the PDF files that are posted from the previous classes, always. And I have many prior semesters if you want to go back and review from the previous semester with test 1 review. So this was an example of a limit being determined algebraically. Let's see what we'd like to continue with.
could we do a difference quotient problem?
Yes. Yes, the difference quotient problem will be already inside a derivative. So for example, let's say I have f of x equals 2x squared minus 4x plus 1, and I'm asked to find the limit using the definition. I'm asked to find the derivative using the definition of the derivative. So that will be the limit as h approaches 0 from f of x plus h minus f of x divided by h. I have to plug it in, so I have limit as h approaches 0 from 2x plus h squared minus 4x minus 4h plus 1, and of course minus 2x squared plus 4x minus 1 over h. We had several examples like this, and in homework, that's another way of reviewing, is with solutions to all written homeworks. Okay, so I can simplify a little bit already. And then I have limit as h approaches 0. Be very careful here. You cannot distribute before you square. And please make sure you do not write two terms. That would be a terrible mistake. So this is x squared plus 2xh plus h squared. And we still have a negative 4h and a minus 2x squared. The other four terms are gone already. So now I distribute 2. Limit as h approaches 0, 2x squared plus 4xh plus 2h squared minus 4h minus 2x squared. And we know that all terms without h must go away. Now I have to be able to factor out h. So I have 4x plus 2h minus 4. I simplify, I apply the limit now. Remember, the limit cannot go away, the limit operator. Now I apply it, now it goes away, and I have 4x minus 4, which I knew from the beginning. So 2x squared minus 4x plus 1, when I differentiate, I have to get 4x minus 4 using the differentiation rules. So I knew what to expect. Okay, here's a question that I would like to go over. Find the points or point on the graph of this function at which the tangent line is horizontal. So here's an example. So we are given, and then you'll select the next one, the next topic. So I have y equals x to the third minus 3x squared, and horizontal tangent line. And this is problem 25 on page 191. How will I address this question? What do I need to do?
Do we differentiate?
Of course, here it is. Excellent. 3x squared minus 6x. Perfect, I did. Perfect, that's the first step. What do I do next?
The slope?
But what is the slope of the tangent line if it's horizontal?
0.
Yes. So the slope is 0. So all I have to do is set this the derivative, which gives the slope of the tangent line at any point. So equal to 0. So I know that x equals 0, first of all, and I have 3x minus 6. And the other option is that x equals 2. So these are the points where the function has horizontal tangents. We know that this function gives the slope of the tangent line. Where it's 0, I don't know. So since I'm asked to find the points, I have to plug it back in. 0, 0, so y equals 0, so one point is 0, 0. And the other point is 2 comma 8 minus 12, negative 4. Because it's asking for the points. I determined the x values, but now I have to determine the y values. Good. Let's see what else we want to look at. Which topic would you like to choose next?